Welcome to another video on equilibrium under the action of concurrent forces. In this video, we're going to solve this problem right here. And the question says a 50 Newton box, this box right here, is slid straight across the floor, right, at a constant speed by a force of 25 Newton. This force right here. Now the question says how large is the friction force that impedes the motion. So this is the friction force right here, impeding the motion. So this guy is dragging this box straight across the floor at an angle of 40 degrees, and then there's a force that is opposing the motion of the box. Okay, it is impeding the motion, and we're asked to calculate how large is this friction force, this guy. And then the next question says how large is the normal force, which is this guy right here. How large is this force right here? And of course the box has a weight acting downwards, which is this guy right here. Alright, so without wasting much time, let's get right into it. To make our work much more easier, let's first draw the free body diagram. Okay, so we have an angle 40 degrees and a force 25 Newton, right? And then we have our normal force is acting upward in the opposite direction to the weight. So this is our normal force, Fn. And then our frictional force is right here, F. And then our weight, Fw, according to the diagram that we can see right here. So how large is the friction force? Alright, so we have to remember our conditions for equilibrium, which says that an object is in equilibrium under the action of concurrent forces when it is not accelerating. So acceleration is equal to 0. The sum of forces, so this is 1, 2. The sum of forces is equal to 0. And the third condition is the sum of forces in the x direction. This is the x direction. This is the y direction. And this is the z direction. Okay, the sum of forces in the x direction is equal to 0. The sum of forces in the, okay, let me write it this way. Sum of forces in the y direction, the sum of forces in the z direction, they all equate to 0. Alright, so we're going to make use of this guy to solve this problem. Okay, so what are the forces in the x direction? The sum of forces in the x direction is equal to 0. So the forces in the x direction, we have F, our frictional force, right? It's in the negative x direction. Now we have a force here which is 25 Newton. We have to resolve this force to the horizontal. Now when we resolve this force to the horizontal, we're going to have 25 cos 40. Okay, and when we resolve this force to the vertical as well, we're going to have 25 sine 40. Okay, so at the horizontal, which is the x direction, we have 25 cos 40, right, for the positive x direction. So positive 25 cos 40, and then the frictional force at the negative, so minus frictional force, and this summation is equal to 0. Alright, so that means that the frictional force is equal to 25 cos 40. When we type that in our calculator, what do we have? We have 19.2 Newton. Alright, and then how large is the friction force? This is the answer to that question. The friction force is 19.2 Newton. How large is the normal force? Okay, so we're coming back here now. What are the sum of the forces acting in the y direction? Okay, and you know that the sum of forces in the y direction must be equal to 0. So what are the forces acting in the y direction? We have our weight. Our weight is acting in the y direction, so let's take note of that. And our weight is acting in the negative y direction. Okay, now what is the weight? The weight has been given in the question. Question says a 50 Newton box. Okay, so this guy is 50 Newton. Okay, the weight of a box acts downwards, all right, at this force 50 Newton. Okay, so we have our weight already to be 50 Newton. Okay, so what other force do we have in the y direction? We have 25 sine 40, which is this force which we resolved, right, to the vertical. And then we also have our normal force. Alright, so normal force and this guy 25 sine 40 both act in the same direction, in the positive x direction. Alright, so we're going to have positive, right, 25 sine 40 plus the normal force, since they're in the same direction, and then negative, this is in the negative direction, minus 50 Newton. Okay, and that will be equal to 0. These are all the forces in the y direction, and summing them up must equate to 0. So this brings us to conclude that the normal force is equal to 25, or let's say 50, right, taking this to the other side, minus 25 sine 40. Okay, so when we do this, what are we going to have? We're going to have our answer to be 33.93 Newton, and this is the answer. This is the normal force. So this answers the question of how large is the normal force. Alright, thank you very much for watching. Don't forget to like, share, subscribe. See you in the next video.